Welcome to Computer Architecture Interview Crashcasts, your go-to podcast for acing those tricky technical interviews. I'm your host, Sheila, and today we're joined by Victor, a seasoned back-end engineer, to tackle a common computer architecture question. Victor, are you ready to dive in?
Absolutely, Sheila. I'm excited to be here and share some insights.
Great. Let's jump right in with our question for today. What are the main components of a computer system, including the CPU?
That's a great question, Sheila. At its core, a computer system consists of four main components: the CPU, central processing unit, memory, storage, and input-output devices.
Excellent start, Victor. Could you elaborate on each of these components?
Certainly. The CPU is often called the brain of the computer. It's responsible for executing instructions and performing calculations. Memory, typically referring to RAM, random access memory, is used for temporary data storage that the CPU can access quickly. Storage, like hard drives or SSDs, is for long-term data retention. Finally, input-output devices allow the computer to interact with the outside world, such as keyboards, mice, displays, and network interfaces.
That's a solid overview. Now, let's focus on the CPU. Can you tell us more about its internal components?
Of course, the CPU itself has three main components: the control unit, the arithmetic logic unit, ALU, and registers. The control unit manages the execution of instructions, directing the flow of data between the CPU and other components. The ALU performs arithmetic and logical operations. Registers are small, fast storage locations within the CPU used for quick data access during computations.
Interesting. How does the memory system work with the CPU?
Great question. The memory system is actually a hierarchy designed to balance speed and capacity. At the top, we have CPU registers, which are the fastest but smallest in capacity. Then we have multiple levels of cache memory, L1, L2, L3, that are progressively larger but slower. Next comes the main memory, RAM, and at the bottom of the hierarchy is the storage system. This structure allows the CPU to access frequently used data quickly while still having access to large amounts of data when needed.
That's fascinating. You mentioned the storage system. How does it communicate with the other components?
That's where the system bus comes in. The system bus is like the highway of the computer, connecting various components and allowing them to communicate. It typically consists of three types of buses: the data bus for transferring data, the address bus for specifying memory locations, and the control bus for coordinating actions between components.
Now, let's consider a more specialized scenario. In modern systems, we often see components like GPUs or TPUs. How do these fit into the overall architecture?
Excellent point, Sheila. GPUs, graphics processing units, and TPUs, tensor processing units, are specialized processors designed for specific tasks. GPUs are optimized for parallel processing, making them ideal for graphics rendering and certain types of computational tasks. TPUs, developed by Google, are specifically designed for machine learning workloads. These components usually connect to the system via high-speed interfaces like PCIe and can have their own dedicated memory. They work in tandem with the CPU, offloading specific types of computations to improve overall system performance.
Thank you, Victor, for that comprehensive explanation. Before we wrap up, I'd like to offer some feedback and tips for our listeners preparing for similar interview questions. First, it's crucial to start with a high-level overview before diving into specifics. Victor did this well by outlining the four main components before elaborating on each. Second, be prepared to discuss how these components interact. The system bus is a great example of this. Lastly, don't forget to mention modern advancements like specialized processors if they're relevant to the role you're interviewing for. A common pitfall is focusing too much on one component and neglecting the overall system architecture. Remember, interviewers want to see that you understand both the individual parts and how they work together as a whole.
Those are great points, Sheila. I'd also add that it's important to practice explaining these concepts in simple terms. In an interview, you might need to adjust your explanation based on the interviewer's background or follow-up questions.
Excellent advice, Victor. Thank you for sharing your knowledge with us today. To our listeners, we hope this episode has been helpful in your interview preparation. Remember to check out our other episodes for more computer architecture insights. Until next time, this is Sheila signing off from Computer Architecture Interview Crashcasts.